Velociraptor existed in a world that was constantly changing, where survival depended not on size alone, but on awareness, intelligence, and adaptability. During the late Cretaceous period, the region that is now Mongolia was dominated by wide desert basins, shifting sand dunes, rocky outcrops, and seasonal waterways that appeared and vanished depending on rainfall. Temperatures fluctuated dramatically between scorching days and cold nights, creating an environment where only highly adaptable animals could thrive. Velociraptor was one of those animals, perfectly shaped by evolution to survive in extremes. Its body plan reflected a predator built for efficiency rather than dominance. Every bone in its skeleton was lightweight yet strong, allowing fast movement without sacrificing durability. The hips and legs were arranged to support an upright posture, keeping the body balanced directly over the legs. This posture reduced energy loss during movement, allowing Velociraptor to travel long distances without exhaustion. The feet were narrow and strong, capable of gripping uneven terrain, sand, and rock with ease. The stiffened tail played a crucial role not only in balance but also in communication. Subtle tail movements may have conveyed emotional states such as alertness, aggression, or readiness to flee. In modern birds, tail position is an important part of body language, and Velociraptor likely used similar signals. The tail feathers, if present along its length, would have amplified these signals visually, making communication more effective even from a distance. Velociraptor's arms were long and flexible, ending in 3 clawed fingers. These arms were not weak or useless, but powerful, grasping tools. The feathers attached to the arms formed wing-like structures that could be spread or folded. While they did not allow flight, they likely helped with balance during jumps, assisted in pinning prey, and played a role in display behaviors. When attacking, Velociraptor may have spread its feathered arms to stabilize itself while using its feet and jaws to control prey. The skull housed a brain that was advanced for a dinosaur of its size. Neural pathways associated with vision, coordination, and reaction speed were especially developed. This allowed Velociraptor to process information quickly and respond instantly to changes in its environment. A sudden movement, sound, or shadow could trigger immediate action, whether that meant attacking, retreating, or hiding. In a desert ecosystem where cover was limited, such awareness was essential. Its eyes faced forward, creating overlapping fields of vision that allowed precise depth perception. This was critical for judging distances during leaps, strikes, and rapid turns. The shape of the eye sockets suggests keen eyesight even in low light, meaning Velociraptor may have been active during dawn, dusk, or even nighttime hours. This would have allowed it to avoid larger predators and exploit prey that were less alert. The sense of smell was also well developed. Velociraptor could likely detect prey, carrion, or other predators from far away. Smell would have been especially useful in tracking wounded animals or locating carcasses hidden beneath sand. This ability made Velociraptor both a hunter and a scavenger, able to take advantage of any available food source. Feathers were one of Velociraptor's greatest evolutionary advantages. Beyond insulation on display, feathers protected the skin from sun exposure, sand abrasion, and temperature extremes. In sandstorms, feathers could reduce skin damage and help regulate body temperature. Downy feathers trapped air close to the body, conserving heat at night, while outer feathers may have helped reflect sunlight during the day. Coloration likely played a major role in survival. Earth-toned feathers would have provided camouflage against sand and rock, breaking up the animal's outline and making it difficult to detect. Patterned feathers may have helped Velociraptor blend into shadows and terrain variations. At the same time, certain feathers may have been brighter or more contrasting, used during courtship or dominance displays. These displays could involve spreading the arms, raising feathers, lowering the head, and vocalizing. Communication was likely complex. Velociraptor probably used a combination of vocal sounds, body posture, feather positioning, and movement to communicate. Low growls, hisses, chirps, or clicks may have been used to warn rivals, attract mates, or signal danger. These sounds would have carried well across open landscapes, allowing communication without visual contact. Hunting behavior was calculated and precise. Rather than chasing prey over long distances, Velociraptor likely relied on ambush tactics. Using terrain features such as rocks, dunes, or vegetation, it could approach unseen and strike suddenly. The attack would involve a leap, gripping with the sickle claws, stabilizing with the tail and arms, and delivering repeated bites to vulnerable areas such as the neck or belly. This method minimized risk and energy expenditure. Velociraptor did not need to kill instantly. By inflicting wounds and maintaining grip, it could exhaust prey and wait for weakness to set in. This strategy was especially effective against animals slightly larger than itself. The famous fighting fossil shows that this method was not without risk, as prey could fight back violently. Survival depended on precision and timing. Juveniles lived very different lives from adults, smaller and more vulnerable. They likely fed on insects, small animals, and leftovers from larger kills. Growing rapidly was essential. And juvenile velociraptors probably spent much of their time learning through observation and experimentation. Mistakes could be fatal, meaning natural selection favored quick learners. Reproduction likely involved nesting in protected areas, possibly near dunes or sheltered rock formations. Eggs would have been laid in shallow nests, possibly covered partially with sand or vegetation. While direct evidence is lacking, related species show signs of nest guarding and parental care. Adults may have protected nests from predators and environmental threats, increasing the survival chances of their offspring. Velociraptor existed alongside many other dinosaurs, including massive herbivores and formidable predators. Avoiding confrontation with larger carnivores was essential. Its speed, awareness, and ability to hide allowed it to survive without competing directly for dominance. This niche strategy allowed Velociraptor to coexist rather than compete, contributing to its long-term success. Evolutionarily, Velociraptor represents a highly refined branch of theropod dinosaurs. It shows how intelligence, feathers, and agility were becoming increasingly important traits long before the extinction of dinosaurs. These traits would eventually culminate in birds, which inherited and expanded upon them. Velociraptor was not a failed experiment or a primitive creature. It was a peak predator for its size and environment, perfectly adapted to its world. Its design was the result of millions of years of refinement, producing a creature capable of surviving extremes, exploiting opportunities, and avoiding dangers with remarkable efficiency. Understanding Velociraptor in its true form changes how we understand dinosaurs as a whole. It reveals a world where dinosaurs were active, alert, expressive, and intelligent. Velociraptor was not just a hunter, but a problem solver, a communicator, and an adaptable survivor. The legacy of Velociraptor lives on today in birds, which still display its feathers, posture, intelligence, and behaviors. Every bird of prey carries echoes of this ancient predator. Velociraptor reminds us that the age of dinosaurs never truly ended, but evolved into the living world around us. Don't forget to subscribe.